How does a non-Newtonian fluid get thick? Imagine a liquid that can switch from flowing smoothly to feeling like a solid in the blink of an eye. That's what makes non-Newtonian fluids so fascinating. They don't follow the usual rules of liquids like water or oil. Instead, their thickness or viscosity changes depending on how much force you apply. The main reason they get thick is a process called shear thickening. When you stir or hit these fluids quickly, their resistance to flow increases. And like water, which stays the same no matter how much you stir, non-Newtonian fluids react to stress by becoming thicker. This happens because their tiny particles are suspended in the liquid and can move apart when at rest. But when you apply force, these particles are pushed closer together. As they get squeezed together, the particles start to jam or lock against each other. This creates a temporary network that resists movement. Think of it like a crowd of people in a narrow hallway. When everyone is standing still, it's easy to pass through. But if everyone pushes forward suddenly, they bunch up and block the way. That's similar to what happens inside the fluid. This jamming causes the fluid to behave more like a solid. The particles form a kind of mesh that resists deformation. This is called an order, disorder transition, or hydroclustering. When particles cluster under stress, they form a network that makes the fluid feel thick and stiff. A good example is Oobleck, a mixture of cornstarch and water. When you move it slowly, it flows like a liquid. But if you hit it or squeeze it quickly, it becomes hard and resistant. This quick change is because the particles inside are jamming together. Some non-Newtonian fluids also have viscoelastic properties. That means they can stretch and bounce back like a rubber band while still flowing like a liquid. This helps them absorb impacts and resist sudden forces. This thickening behavior is useful in real life. For example, impact-resistant body armor uses non-Newtonian fluids. When hit, the armor stiffens instantly, protecting the wearer. Speed bumps made with these fluids can also harden under the weight of a car, providing a safer, more flexible solution. So, a non-Newtonian fluid gets thick because the particles inside it rearrange and jam together when stressed. This increases friction and resistance, turning the fluid into something more solid like temporarily. It's a strange but amazing way that physics and chemistry blend to create materials that behave in surprising ways.